Hello, I'm going to be covering 3.2 division polynomials. And in this section, we're going to look at long division and how to divide polynomials. To start off this problem, we're going to go ahead and look at 7 dividing into 38. And we're going to go through the steps on how to do that. So the first step you always ask yourself, what do I have to multiply 7 by to get something between or less than 38 but not higher than 38? In other words, how many times does 7 go into 38? And we know it's going to be 5 times. Now when we do that, we write 7 times 5 will be 35. So that gives us that. We're going to subtract the 2. And if you notice, 38 minus 35 is going to give us a remainder of 3. So if I was going to write my answer, it would be 5 with a remainder of 3. So that's how we would approach this problem if we were dividing a regular two values. Now when it comes to polynomial, we're approaching a similar concept. But the idea is we're going to look at that first term. Every time I look at it, I'm going to look at that first term and ask myself, okay, I look at that term and that term, and I ask myself, what do I have to multiply x by to get 3x cubed? Well, to do that, I have to multiply by 3x squared. Because if I multiply 3x squared and x, I do get 3x cubed. And my goal is to match that first value. So since I've matched that first value, I can go ahead and multiply my second value, which is plus 3. So what's 3x squared times 3? That obviously gives us a positive 9x squared. Now, just like what we did in the previous problem, we would subtract the numbers. Exactly what I'm going to do here. I'm going to subtract 3x squared, and I'm also going to subtract 9x squared. So when we do that, we're going to get 3x cubed minus 3x cubed. That's going to be gone. However, 16x squared minus or plus a negative 9x squared is going to give us a positive 7x squared. This term is going to come down to give us positive 21x. So now I'm going to look at that term, again the beginning term, and ask myself, what do I have to multiply x by to get 7x squared? Hopefully by now you're realizing that it's going to be positive 7x, because 7x times x is going to be positive 7x squared. And again, I want to match that first term. But from there, I would go ahead and multiply my second term, which would be 7x times 3, which gives me positive 21x. Now remember, just like in a regular division, we're going to do the opposite of what's in. So it's positive here, we're going to subtract them, and we get the following. 7x squared minus 7x squared gonna give you 0. And then 21x plus a negative 21x is also 0. So in this problem, we actually get no remainder. Now, what do I get as my answer? Well, my answer is going to be two of these factors. It's going to be the first one that we divided by, and my answer that I got on top. That's going to be my second factor. So my complete answer would be my two factors. The first one is x plus 3 and 3x squared plus 7x. Now notice that's my answer. If I go back and distribute that, I will get 3x cubed plus 16x squared plus 21x. Now this is me going back if I distribute that. If I don't, that will be my two factors. Let's look at another example here that we have, example C. So again, look at the first term. We have x here and we have 8x cubed. Ask yourself, what do I have to multiply x by to get 8x cubed? And the answer to that is 8x squared. So 8x squared times x gives me 8x cubed. Remember, now I'm going to multiply 2 by 8x squared. So when I do that, I do get positive 16x squared. So from here, I'm going to subtract my values. So let's make this negative and make that negative as well. So 8x squared minus 8x squared, that's obviously is going to be 0. But look what happens here. We have negative 3x squared plus a negative 16x squared actually gives us negative 19x squared. Bring down the positive 2x like you would in a regular multiplication or division problem. Now let's go ahead and again we're looking at the first term here compared to the first term with it, which is the x. So what do I have to multiply x by to get negative 19x squared? And the answer to that is going to be negative 19x. So now I would have to multiply negative 19x by x to get negative 19x squared. And also negative 19 times 2, positive 2, would be negative 38x. Now going back and adding this, and since this is negative, I'm also going to add that and then combine them together. Negative 19x plus 19x will give you 0. And then 2x plus 38x gives me 40x. So now I go ahead and bring the next term down, which means I have a minus 1 here. And again, I look at that first term, which is 40x, and I ask myself, what do I have to multiply x by to get 40x? And the answer to that would be plus 40. So I'm going to multiply both terms by 40 by x and by plus 2. So we get 40x, and then 40 times 2 be positive 80. So now the only thing that's left is subtract both of those because they're both positive. So that's going to give you 0, and this will give you negative 81. So my answer to write this answer, as I said before, the two factors are going to be this value here and that value here. But in this case, we do have a remainder, which is a negative 81. So to write this answer as a complete solution, we get x plus 2 times 8x squared minus 19x plus 40 plus the remainder is negative 81. And remember, you always divide by the same denominator, which in our case is x plus 2, because that's what we were dividing by. And so my answer is going to be, or my complete answer, if I write it out loud, is going to be x plus 2 times x squared minus 19x plus 40, plus the remainder, which is negative 81 divided by x plus 2. We have what we call a division algorithm. This is what it states. The polynomial of x, or the function of that x, is going to be d of x, okay, or as we call a divisor, times the quotient, the q of x, plus the r of x, or as we call it, the remainder. So I'm going to write them all out. Okay, so this is what we call dividend. This is the divisor. We have a quotient. and we have the remainder. So this is the division algorithm. It consists of a dividend, okay, and that dividend is our divisor, as you can see here, our quotient, as you can see there, and our remainder, as you can see there. So that's how we would visualize those three things that I just wrote down. So the process that I showed you is called lone division. This is the process we do when we are solving using lone division. There's another way to divide two polynomials, and that is called the synthetic division. Synthetic division may be easier sometimes, but again, it really depends on what you have and how you feel, what do you feel comfortable of doing. The thing is, with synthetic division, you have to be really careful and make sure, actually with lone division as well, is you need to fill in all the missing exponents that are required. As you can see, our first or the highest exponent is to the third power. We don't have x to the second, we don't have x to the first power, and we do have our constant. So if I'm going to have, if I'm going to use the synthetic division, I have to make sure I look at the coefficients, which is the numbers in front of the variables. So in this case, I have x cubed, but then I need to add a 0 of x to the second power because I'm missing the x squared. I'm also missing x to the first power, and then I have plus 27. So I do need to have all of those written down. Now, the other thing we need to talk about is how do we get the c? The c is what we call the root. And so if we look at this factor, which is x plus 3, this factor, if I bring it down here, is the same thing as x plus 3 is equal to 0. In other words, x is equal to negative 3. So the negative 3 here is your c. That is what we're going to be dividing by, and that's the thing that's going to be in front of our division. So in this case, we don't actually have x's, or we don't have any variables in our problem. We just have coefficients. So my x, or my root, is going to be negative 3. My coefficients of this whole thing is going to be 1. That's x to the third. The coefficient here is 1. X squared is a 0. X is a 0 as well. And then the constant is going to be 27, positive 27. So the way this works is as follows. Take the first term, bring it down, which gives you a 1. Take negative 3 multiplied by 1. Negative 3 times 1 is negative 3. So now take 0 plus negative 3 is negative 3. Now take negative 3 times negative 3 is actually positive 9. So 0 plus 9 is going to be 9. So now go ahead and take 9 times negative 3, which is also going to be negative 27, and we get 27 plus a negative 27, which is 0. So this means we have a remainder of 0. So how does this all work out? What does that mean now? Well, this actually happens to be, this statement here happens to be the following. Remember, we started with x to the third. So now everything else is going to be 1 degree less. So 1 is going to represent 1x to the second. Negative 3 is going to represent negative 3 times x, or the x, which is the x to the first power. And then since I have the 9 here, that will be positive 9. So that's going to be your first factor. We also had the factor here that we started with, and we got this factor here that I have here. So those two are going to be multiplied. So we get x plus 3. So your answer actually is going to be as follows. Is those two multiplied. So let me write that. So it will be x, and again, we don't really need that 1 in front of the x squared. So it will be x squared minus 3x plus 9 times x plus 3. And so my final answer is going to be what's in the box. So let's look at a similar problem here. Again, remember this is going to be, so we start off with this hockey stick, if you want to look at it that way. Take your first coefficient, which is the highest exponent, which is a 5. Your second highest would be -2. Your third one will be +1. And then your last one is -10. Remember, how do I get this number? Well, that number comes from there by solving for x. So you would have to x minus 3 is equal to 0, and x is equal to 3. So my value here is actually going to be 3. So that means I can get rid of that. And so now I'm going to divide that 3 into those things. Now again, take the first term, bring it down, and you get 5. So I'm going to use a different color to show you kind of what's happening here. I'm going to take 3, I'm going to multiply it, and I'm going to write the number here. So 3 times 5 is 15. Now add those numbers together. So it will be -2 plus 15, which is actually 13. Now take the 3 again, and this time multiply by 13 and write the number there. So 3 times 13 is 39. Add those two numbers together, which gives you 40. Now take that number, take 3 and multiply that by 40, and you get this number, which is 120. So in this time, if you notice that -10 plus 20 is not 0, it actually gives us 110. So that creates a remainder, and we're going to go ahead and write our answer. So remember, this 5x is not going to be 5x to the third, it's going to be 5x squared, because it's going to be 1 degree less. So we start with our the first factor, which is x minus 3. Then I'm going to multiply by 5x squared plus 13x plus 40. I'll close that parenthesis. And I do have a remainder, which in my case would be plus 110 divided by, and remember, I'm dividing by x minus 3, so that's my denominator, which means I have to make sure I keep that denominator, which is still x minus 3. And that would be how we use synthetic division. So our answer is going to be x minus 3 times 5x squared plus 13x plus 40 plus the remainder, which is 110 divided by x minus 3. The remainder theorem states the following. If the polynomial p of x is divided by x minus c, which is one of the factors, then the remainder is the value P of C. So let's go ahead and look at what that means. It says use the synthetic division and the remainder theorem to evaluate P of C. So let's see what's happening here. So again, using the synthetic division, we would start off with drawing the hockey stick. Then we have a 2 as our first coefficient, negative 7 as our second coefficient. Because I don't have x here, it's going to be 0. And then followed by the constant, which is 5. Now remember, x minus 3, when you solve for x, you get positive 3. And that's how I get the 3 in front here. That's what I'm going to be dividing by. So bring down the 2, which gives me 2 on the bottom. 3 times 2 is going to be 6. Add the two numbers together gives you negative 1. 3 times negative 1 would be negative 3. 0 plus negative 3 would be negative 3. And then 3 times negative 3 would be negative 9. And then 5 plus negative 9 is actually negative 4. So if I were to write the answer to this problem, this actually is going to look the following. So you're going to have x minus 3 is your first factor. Your second factor is going to be 2. Remember, it's not going to be x to the third, it's going to be 1 less, which means it's going to be x squared, minus x minus 3, close the parenthesis, and then you're going to add the remainder, which is negative 4 divided by, remember what we were dividing by was x minus 3. So we still have that. So that would be our complete answer. Now what the remainder theorem says is that since our remainder was actually negative 4, then that means if I take c, which is this value here, remember c is the thing that x minus c, remember c is x minus c here, and so when I solve for x I get c, and that's how they get that c. So if I take 3 and I take this equation here, remember this is the equation they gave us, P of x is equal to 2x cubed minus 7x squared plus 5. What they want us to do is take that c, which in our case is 3, and substitute it for x and see what we get. We get 3 cubed minus 7, 3 squared plus 5. Well, that gives us 2 times, 3 cubed is going to be 27 minus 7 times 3 squared, which is 9, plus 5. 2 times 27 is 54 minus 63 plus 5, and doing that gives us negative 9 plus 5, which is actually negative 4. So what they were trying to do is they wanted to show you that when you plug in your c, you also get a remainder of 4. Notice those two are equivalent. So those two are equivalent. And that's what a remainder theorem is actually stating. If you have, or if you know your c by plugging in that c into the original function or the original polynomial, you do get the same remainder if you were to use long division or synthetic division. Really does not matter. So let's go ahead and look at that one problem as well. Again, start with the hockey stick. So we get 8 minus 2 plus, well, we don't need to put plus, we can just put 10. Then we have a 1, negative 20, and then 10. And then remember that c is going to be, if I solve this x plus 2, I get negative 2 as a result. X is equal to negative 2. So let's go ahead and plug all this information in. Bring down the first value, which again, if we do that correctly, we get 8. Well, negative 2 times 8 is negative 16. Negative 2 plus negative 16 is negative 18. Negative 18 times 2 would be positive 36, which gives you 46 when you add those two numbers together. Negative 2 times 46 would be negative 92. And then adding 1 to it would be negative 91. Negative 91 times negative 2 would be positive 182, which gives me 162 when I add those two together. And then you get negative 2 times 162 gives us negative 324. Adding 10 and negative 324 gives us negative 314. So this gives us a factor with a remainder of negative 314. Now let's plug negative 2 into the original function. So let's plug in negative 2. We get 8. Take negative 2, raise that to the 5th power, minus 2 times negative 2 raised to the 4th power, plus 10, take negative 2, raise that to the 3rd power, plus negative 2 squared, minus 20 times negative 2, and then plus 10. And if you do your math correctly and you plug everything in and make sure you follow the order of operations, you will get negative 314, just as stated by the theorem. Those two will be equivalent. A factor theorem states the following: C is a 0 of P, or the polynomial, if and only if x minus c is a factor of the original polynomial. So what does that really mean? Factor theorem. C is a 0 if P of P, if and only if x minus c is a factor of P of x. Basically they're saying that, well, something will factor if you're given a specific c and you realize that, hey, this c works, then it actually is a factor. So c is going to be the factor of x minus c. So let's look at this first example. Let's assume I give you c is equal to 1. Again, this is me giving you that number, and I'm asking you, okay, is c 0 of p? And then if it is, then you know it's going to be a factor of P of X. Well, let's check our solution. P of 1 is equal to In our case, we're replacing x with 1, so that'll be 1 cubed minus 7 times 1 plus 6. As you can see, we get 1 minus 7 plus 6. And last but not least, we get negative 6 plus 6, which is equal to 0. Well, what does that tell you? That tells you that since c is equal to 1, that means one of our factors is going to be x minus c, which means it should be x minus 1. So that's going to be one of our factors. Well, since I know x minus 1 is going to be one of my factors, I can figure out what my other factor is by, well, we can use synthetic division. Remember, c is 1, so that's going to be here. X to the third has a coefficient of 1 in front. I do not have x to the second, so that's why I'm going to put a 0 there, placeholder. I do have a negative 7 as my coefficient in front of the x. And last but not least, I do have a 6 as my constant. So again, bring that down. So that gives us 1. 1 times 1 is still 1. That gives me 1. 1 times 1 is still 1. That gives me negative 6. 1 times negative 6 is negative 6, which does give us 0. So my two factors are going to be, one of them is going to be x minus 1. We figured that out when we plugged in 1. The other one, though, is going to be x squared from the first coefficient. The second coefficient is 1 as well, so that'll be plus x. And the last one will be minus 6. Notice we do get a 0 here, so there is no remainder. So my two factors would be x minus 1 and x squared plus x minus 6. So a similar problem, and I'm going to give you a c. Let's say c is equal to 5. Well, we have no idea if this is going to work or not. If it does work, if we do get a 0, that means it's one of our factors. However, if we don't get a 0, that means you cannot use it as one of your factors. So let's see if it actually works. P of 5 is equal to 5 cubed plus 21 times 5 squared minus 157 times 5 plus 135. So let's see what we get for P of 5. So that's going to be 125 plus 525 minus 785 plus 135. Continuing combining like terms, I get 650 minus 785 plus 135. Again, continuing with that, I get negative 135 plus 135, and clearly that is 0. Having said that, that means one of our factors is going to be x minus 5. So that's one of the factors. I still have to find the other factors. However, I can use synthetic division now by putting 5 in front and using that hockey stick. I can write 1 for the x squared. I can write 21 for the x squared. I can write negative 157 for the x, and for my constant is 135. So again, bring the first thing down. We do get 1. 1 times 5 is 5. 5 times 5 plus 21 will be 26. So now we go 5 times 26, which is 130. That, adding those together, gives me negative 27. And negative 27 times 5 is negative 135. which does give us a 0. So my first factor is going to be x minus 5. I know that from plugging in 5 into my polynomial. And my second factor is going to be x squared plus 26x minus 27. And remember, we got a 0, so there is no remainder. So my answer is as follows. Questions? Well, I can't really answer questions. It's a habit. Sorry, guys. But if you do have questions, I'm sure someone can help you. All right, finding the polynomial of specified degree. Now, notice what it's saying. It says you have a degree 3, so that means you have something like x to the third power. That's what that means. Now, it also tells you the zeros. What zeros mean that you have x is equal to -4. You also have x is equal to 4. And you have x is equal to -2. So that is your zeros. However, remember, I can go backwards by adding 4 to this side and get x plus 4 is equal to 0. I can get x minus 4 is equal to 0. And then I can get x plus 2 is equal to 0. So actually working backwards, I got my 3 factors. X plus 4, x minus 4, and x plus 2. All I have to do now is multiply them out. So I have x plus 4 times x minus 4 times x plus 2. So doing that, I get x times x. So let's go ahead and factor this one out first by multiplying or by distributing. And then we're going to distribute the 4 as well. So by distributing the first 2 factors, we get x squared. We get plus 4x, then minus 4x, which gives us 0. And then 4 times -4 will be -16. So that will be the multiple of the first 2 factors times x plus 2. So going through the same steps, I'm going to multiply that, and then I'm going to distribute that. Again, using distributive property, I can figure out what that is. So let's go ahead and do that. X squared times x gives me x to the third, which is a good thing. I do need a degree 3. Then x squared times 2 will give me positive 2x squared. Then -16 times x will give me -16x. And -16 times 2 gives me -32. And because I can't combine any like terms and I cannot put anything together, that is going to be my complete answer. That is going to be my polynomial that has a degree of 3 and has those zeros, which is -4, 4, and -2. Similar concept, degree 4, which means this time it should be x to the 4th or something of that sort. Now remember, my zeros are going to be x minus or x is equal to -3, x is equal to 0, x is equal to 1, and then x is equal to 5. Which means if we got going backwards, I should get x plus 3 as my factor. X equaling 0 is equivalent to just x. I mean, you could put x plus 0, but it's not necessary. The second factor should be x minus 1. And the last factor should be x minus 5. So let's start easy. X times x plus 3 will give us x squared plus 3x. That would be my two factors multiplied together. So these two multiply together. Then I have x minus 1 and also x minus 5. So let's use distributive property to multiply these two. So let's see what we get. We get x times x, x squared times x, which is x to the third. X squared times negative 1, and then 3x times x is going to give us 3x squared. So you have a negative x squared and a negative x squared and a positive 3x squared, which gives us a positive 2x squared. And obviously last but not least will be 3x times negative 1, which is negative 3x. So that gives me the factor of that, and I do still have one more to multiply by. So in this case, that should be 4. I don't know why I had, it should be x to the fourth. So in this case, we would again distribute the x to the third, and then I would distribute those two. Actually, let's make it a little bit simpler and go the other direction. We can multiply by this. So we only have to do that to the two terms. And then I can actually do the same thing with the following. It really doesn't matter which one you do, but as long as you do it correctly. So let's see what we get. X to the third times x will give us x to the fourth, which is a good thing. That's degree 4. 2x squared times x will give us positive 2x cubed. Then negative 3x times x will be negative 3x squared. Then negative 5 times 3x squared will give us negative 5x cubed. Negative 5 times 2x squared will be negative 10x squared. Negative 5 times negative 3 will give us positive 15x. Notice we do have like terms. We have x cubed, we have another x cubed, we also have x squared, and we have another x squared. So let's go ahead and put them all together. We get x to the fourth. 2x cubed minus 5x cubed will give us negative 3x cubed. Negative 3x squared plus a negative 10x squared will give us negative 13x squared. And last but not least, we have positive 15x. And that will be our polynomial, a specific polynomial that has a degree of 4 and has zeros at negative 3, 0, 1, and 5.